start quickly by talking about Discovery and the capabilities and where the product fits into the Ansys product portfolio, because it's a unique product. It's something brand new. Well, not really brand new. It's been under development for 8 years, but I think as far out of an industry point of view, it's a new technology to be able to do more rapid engineering, especially for design engineers. So the traditional way to do simulation is you'll get a CAD guy, he'll create some geometry, and you will do some concept phase simulation, which will be handed over to a single guy with thick glasses in the corner office, and he will spend a couple of weeks doing simulations and then come back with a report. If you're using CAD embedded simulation, that will be a bit quicker, but it will still take some time. But what we've got with Ansys here, Ansys Discovery, this is real-time simulation. So this is like, I always call it gaming for engineers, because you have got very rapid results when you make changes. And I'll show a bit of that in the demonstration today. I just want to go over a couple of slides so you can see what the full capability of the software is, because I can't do all of that in 45 minutes or half an hour or an hour even. The goal of the software is to increase innovation and to be able to make rapid decisions while you are busy developing or designing a new product. It will increase your productivity, it will increase your quality of your prototype that you will build, and it will enable you to do innovation at a much faster pace. We've done some case studies with South African clients with the Ansys Discovery. And the cool thing about it is that when new concept is born, it's very quick to sit in a room with a couple of engineers, come up with ideas and test some of those concepts before you start actually modeling the prototype geometry. It still sits without the CAD environment. I mean, the CAD environment, all the CAD tools, SolidWorks, Inventor, and Creo, all these tools are meant to create detailed manufacturing drawings to make something, right? And maybe to test some mechanical multi-body dynamics, or to see how parts will move relative to each other, etc. But this tool fits in between the CAD and real simulation software like Ansys Mechanical or CFD. You will see some return on innovation kind of quotes there that the director of Moffat Corporation, their design time was cut in half. And these are really true things. Even for South African companies, we find that the improvement in efficiency in the organization is really like double the time to be able to do these things. Right. Once I figured out how to advance my slides, I will go to my next one. Yes, there we go. Right, I'll open up the software now so that you can see the interface and how it interacts with the user. But basically, in a nutshell, there's a geometry preparation included in the software. So you can create geometry from scratch. You can modify geometry coming from somewhere else, scan geometry, or this used to be Ansys SpaceClaim. So it's an extremely powerful CAD tool meant for simulation. If you're doing simulation, you don't want all the welding gaps to be in there. You don't want all the holes to be there because they are irrelevant, for example. So to remove those things, it's excellent at doing that. The user experience is really very innovative. It's an excellent way to model and work. You can see everything on the same screen. It's a very simplistic menu system at the top with very little commands, but it's really very powerful commands. You'll see some of the commands in my demonstration in a while. So as far as geometry preparation go, you can import CAD files into this geometry part or the modeling part. You can very quickly clean up things. You can edit geometry that you created previously. And it's really very good at converting faceted data to surfaces or solids. So if you've got some scan geometry and you want to create geometry from there, this is really where Ansys Discovery excels. Then there's a fluid simulation part, which I'm going to show a bit about today. This is for internal and external flows, mostly. This is not for free surface flows like water in a channel, etc. So there are some limitations with this software. But if you have to look at some internal flows or some external flows and you have to to alter a couple of design parameters and come up with the initial prototype idea, this is excellent to do that. There's also a fully functional topology optimization tool inside Ansys Geometry Discovery modeling. And what it does is it actually will do a stress analysis, and it will remove the nodes or the elements that doesn't carry any stress. And it will come up with an optimized shape that will still be able to handle the loads that it experiences, but it will give you this shape. This is excellent for people in the additive manufacturing industry, where they are looking to 3D print some of these components. But it is also a very handy tool for engineers to see where they can remove material from a standard bracket to still comply to the design specification. Then it's got a full-blown stress analysis tool in there. And this includes nonlinear contact and joints for realistic assembly interactions. You can do pre-tension bolts, large deflection for enhanced accuracy, and it gives you instantaneous results. I'll quickly show something on how that works in my demonstration for you guys as well. Right, then modal analysis is very important. As a preliminary kind of analysis with every single analysis you do. I mean, if you're a regular FEA user, you always start with a modal simulation to see if everything is fixed, etc. And that will give you the natural frequencies of the design so that you can keep them away from the motor operating frequency, or if it's a pump or a rotor, the blade pass frequencies, the harmonic frequencies, or the whatever frequency gets excited by the driving components. Then the thermal simulation is very strong. This is used a lot in electronics, where you've got a PC board with some heat sinks, etc. You want to optimize the heat sink or see how big it must be. You can do that thermal simulation. Back in the day, Ansys sold something called Ansys IcePack, and that was specifically for doing electronics cooling. And in my opinion, it still exists, that product, but this is really taking over that product entirely at a fraction of the cost to be able to do these thermal simulations for electronics. This is also applicable thermal to any kind of thermal simulation where you're heating something up, and it will give you boundary conditions, convection, heat, insulation, and temperature conditions. Right, and then I think the powerful thing about this is what's next. If you are finished with the concept things and you want to go over to a more detailed analysis, you can transfer this to Ansys Full Mechanical or Ansys Full Fluent. There is another way to go to the refine mode, which I'll show you in my demo. There's 3 modes in Ansys Discovery. I'll explain that a bit later. But this will take the model and the mesh and everything that you did in Ansys Discovery modeling and directly transfer that to the flagship solutions from Ansys. And you can continue detailed simulation there further with more detail, maybe some chemical or phase changes, maybe some crack propagation, etc., fatigue analysis, instructional, whatever the case may be. Right, and this is just a capability chart. We'll share the capability chart with you guys after this webinar. But it's a very, I would say it's a very broad application set. It competes very well with CAD embedded simulation functionality-wise or capability-wise. The only difference, obviously, being it's a separate tool. It's not tying up your CAD system while you're using it. So if you've got floating CAD licenses, the guys can carry on with that. And the designer can access one of these floating licenses and he can use it. And the depth is comparable with what you get in CAD simulation or embedded CAD simulation. Right. I'm going to switch over to the software now so you can see that. So let me close this. And I'm going to open it up from scratch so you can see that I'm not playing a video. Can everybody hear me? Is everybody still there? I've got no feedback of who's in the meeting. So am I still in the meeting?
Yeah, can hear you.
Fantastic.
Yeah.
I would hate to finish my whole demonstration and then I've never been in the meeting because the internet dropped or something. That will be a bummer. All right, I'm working on 2024 release 1. And this software runs mainly off your GPU card, the computation side. And then your CPU is being utilized for geometry modeling, for some of the graphics. Your graphics card is being used. The graphics card that I'm using is a 3060 GeForce card, so it's nothing fancy. You get much faster and better cards. And one thing to note, though, is that even though I'm the sales guy for QFin practically, so my laptop isn't what the technical guys' laptops are with 4080s and 4090 cards. But the better your GPU card is, the quicker these things will happen for you, especially on the simulation side. Right. What you see in front of you is the software interface. This is a very intuitive user interface. You will see that I'm in the design tab now. That will allow me to create geometries, all kinds of geometry modeling. Then there's a display tab that will allow me to manipulate display things. And then there's a measure tab. You can pull all kind of information from the geometry on hand. And then there's a whole tab for facets when you've got scanned geometry coming in, and for repairing geometry. If you're importing things like STL files or Parasolid files, then there's some problems. It's very, very powerful with that. And then there's a prepare tab to prepare your geometry for simulation. And then there's a simulation tab. And we're gonna go over all of these things in the next couple of minutes. Right. I think let's first. I'm going to show you a bit of the modeling, because that's really where this thing excels if you're starting with a new concept. And my example of choice is a Venturi mixer. I don't know who's familiar with that. It's typically, do you know what the Venturi mixer is? Let me show you. This is a Venturi mixer. So what's basically happening is you've got flow coming on in the inside, and you've got some flow going out to the outside, and then it will suck up some fertilizer or some gas or some liquid, and it will mix it inside this thing. And then the outlet will contain both fluids. That's a very good example of this. This is the irrigation one. That's typically what mine is based on. So let's just make a couple of observations here. This is the inlet side. And then it narrows down, which speeds up the flow. And then it will create a low pressure zone around here somewhere, which will suck up some of the liquid that you put on that side. It will mix it in this chamber and it will spit it out on the other side. Right, that's a very good explanation of what it is. Right, so let's draw that quickly. I'm going to start with selecting two of those axes. And I'm going to create a circle. I'm going to start it from the center. So let's make that a 10mm diameter little circle. And then we've got this powerful thing in Discovery called the pull tool. And I can extend that to, let's make it a long one, just for 20mm. That'll be the center section that I'm going to model. The nice thing about Discovery is I can copy faces and paste it. I've just done that, by the way. And then I can move it along. So let's move this one. Let's make it move it about 40mm along. And then this pull tool also works wonderfully if you select the edge there, and you can offset that by 5mm. That will make it a 20mm circle. And I'm going to do the same for this side. I'm going to copy that face. I'm going to paste it. I'm going to move it out. This time only 20mm. And then I'm going to pull that bigger. Or bigger. Right, and then I can create the loft bodies by selecting two of these. Let me first do this, right? Let me just pull that thing 20mm that side. I've got essentially three solids now. Right, and then I'm going to create a lofted surface between. You can select the edges like I'm doing there. It will do that for you. All right, I can also select the faces, and it will give me a bit of a very nice shape in there, which I can do. Don't really want to do that right now because my demo hasn't been prepared in that fashion. I'm going to make some changes. Right, now we need to put the inlet on the bottom of the suction pipe. So I've selected two axes. I'm going to create a plane there. Then I'm going to move that plane down. Let's move it about 20 millimeters down, and then I can go now and I can draw on this plane, yeah? So let's draw on that, view it normal, and I'm going to make a little suction pipe of 8 millimeters. And then I can pull that suction pipe up to next and select that surface. And there will be, let's make it a bit fancier by creating a fillet into that edge there. You will see I selected a pull tool and I selected the whole edge and I'm just dragging that out and I'm giving it a 1 millimeter radius. We'll make it a bit more smooth. Right, this plane I can delete now. I don't need that anymore. Right, just a quick thing on this pull tool. I can select any face and I can actually make it bigger and smaller. As I would like to do that, I can move this out. It's free-form modeling, so there's no tree on the left-hand side where if you delete that, if I delete that face, it will tell me I can't because there's a fillet attached to it. All that, it's really free-form modeling. This is excellent for testing concepts, for editing geometry, etc. Right, the last thing I need to do is to just shell this whole thing and select all the faces that I want removed from this piece and give it a shell thickness. Let's make a shell thickness 0.5 millimeters. And then that will be my Venturi mixer. You can see there's a nice gap on the inside. All right, so there's my initial design, let's call it that. Right, the next step will be to, I'm going to do a fluid flow analysis where the water is coming in from this side and it's exiting on this side, and then there will be some low pressure sucking up some liquid on the small Venturi there. I need to create a fluid volume because the simulation will run on a fluid volume, and I have to define that, right? So I'll go to the Prepare tab. It's very easy to do a volume extract. It tells me to select all the capping faces. So I'll select that capping face. I'll select this capping face. And there's the last one here. And that will enclose the geometry. And then I just have to give it a seed face so that you can calculate the fluid volume. And you will see up here in design, there's a volume, right? That's that volume. There's the solid. And we can hide that solid now because we don't need it anymore. I'm just hiding it. I'm not putting it completely away. So that's the fluid volume, and it's ready to be simulated. Right. I need to assign a material to this. I think one thing I would like to do is to tell it that this is water. You can make it a gas also if you want. I think water is a more touchable substance in our case because we all know what water flows like and what it feels like and how heavy it is. So that's great. Right. And I'm going to start to see. I've got no idea what these sizes should be. I just pulled them out of my head. And my experience with designing these things is 0. So I need to optimize a couple of things now. Right. So let's go to simulation now. And I'm going to tell it I want to do a fluid flow simulation. I'm going to define some conditions. It's asking me for an inlet, so I'm going to define this is an inlet, and I'm going to give it a pressure. Now, usual water pressure on your water outlet in your house should be around 150,000 pascals or 1.5 bar. That's one inlet. I'm going to define a second inlet. This is a suction pipe, so I'm going to define there a pressure of 0 because that will be open to atmospheric. We'll see the inlet conditions are being listed here. And then I want to define an outlet. Yeah, goes out. And I want to give that a pressure of, let's give it a bit of back pressure, half a bar or so. Right, you can see there's my conditions. Just notice how if I go to these things, I'm able to click on that little button that will add as parameter. So if I can put the analogy between a CAD like SolidWorks with parametric modeling, where you can change things afterwards, Discovery is a parametric simulation package. So it's very easy to define parameters in this way. Right, the only decision I have to make is if I'm going to switch on gravity. If the flow is fast enough, I don't have to switch on gravity. I can if I like. I'll just put it on. And then I'm ready to solve this thing. So here we go. Let's solve it. Let's see how long it takes. It's starting to develop. I'm plotting velocity here. Let's look at it from the side, maybe. It's a bit of a better idea. We should see some high velocities in the beginning here. You can hear, I don't know, you can't hear my graphics card, but my GPU is starting to run a little bit. It's searching for a steady state solution, and once it has it, I can do different kind of plots here. So I'm able to plot streamlines, for example. Take that away to show me what the flow looks like. I can make the particles move like this, and we can see starting to speed up there, and it's starting to pull in some fluid into that region. There's a lot of recirculation in here. If your intention is to mix some of this fluid with that fluid, that's excellent. That's kind of what you want. But now I need to see how effective is this, right? And how much fluid does it pull in here, etc. So let's change it a bit. I know from what I've seen on the internet that this little diameter there is still a bit big. So let's change it, right? Let's just get a nicer graphic going. No, that's not very nice. It's kind of, that's okay. All right. So while it's busy simulating, it's running off my GPU, remember, I can go to the geometry tool, the tool tool, and I'm going to change that from a 3.5 millimeter radius to a 2.5 millimeter radius. And you will see that immediately the solver will recalculate the results and it will display it to me in this fashion. Right. Can I just, yes, can somebody say this is cool, please? I feel like I'm doing a demo to myself. I've got no faces. That's fast, eh?
It does. It is impressive.
Okay.
Interesting.
So maybe you guys can realize now how this tool fits into engineering tool set is where you have to come up with a design that's workable and then optimize it a bit. And that's exactly where the software fits in, right? Let's make another change. Let's make that diameter a bit smaller. So the fluid, the fluid should, oh, I broke it now. I didn't really break it. The solver is still solving. You see where my Venturi is coming in now. You can see this mixing region there. So it's actually updating. It's solving that whole thing. It's building a mesh. That's fantastic. I'm impressed by that. I wasn't supposed to do that. I want to move things around a bit first. I can pause the simulation at any time, like here, and I can make some changes, right? So even if I go and I move this edge there a little bit further, let's move it by 5 millimeters. I can tell it to solve the simulation again, and it will go. It's solving for a steady state simulation currently. You can set it to be a transient solution in here. There's simulation options and calculation type. It's now static. I can set it to a time-dependent study, and it will update, and you will see now how the flow develops. Let's just look at some vectors here. You can see initially the flow is coming in, it's pushing out there, and then the solver will, as it starts developing, it will sort that out, and then the flow will start pulling into there. So it's good to give it a couple of minutes to settle. On a very fast graphics card, this will happen almost instantaneously. With me, you can see there we've got nice flow going in. I can also set some parameters, the thickness of the lines. I can make them a bit thinner. If I want to look at pressure, I can go to the static or the total pressure here. Give me the pressure difference between this. The transient is obviously taking a time to develop the flow. I'm going to switch back to static because I want to show you the cool thing about the software. It's coming. Like the particles, for example, I can make them bigger, make them smaller. So I always had this joke and said that this is CFD is colors for directors, and it's very true because the moment you put color and movement to anything, it really becomes very understandable to non-engineer people. Right, there's a good idea of what's happening. Let's look at the flow lines. It's looking much better here. All right, let's play around with this now a little bit. Let's just do that. Save a bit of resource. I can go now and define some monitors, right? So let's say I'm going to select that face there, or that inlet basically. And I'm going to ask there for a mass flow or volume flow. I'm going to tell it, okay. So you will see this little thing appears. And it's a graph of the current design point. And it gives me a result as well of, that will be 0.0264 kilograms per second. Kilogram is roughly a liter, so that's roughly 264 milliliters of water per second, which is quite a nice. If you had to buy all that fertilizer or liquid fertilizer to go in there, that will be quite expensive. So we want to reduce that maybe a little bit, or maybe you want to increase it to make the mixing more efficient, etc. It depends on the application. Let's define a couple of more parameters. This is now monitor, so I'm just merely monitoring this. So if I change something here, let's change the input pressure to 2, 12, 2 bars. Let's run it again. Right, we can monitor how that will change. So it's very cool to play around with it. That's why I'm calling it kind of gaming for engineers. You will see that my mass flow rate has increased quite tremendously by changing the inlet pressure. So if I lower it back to 1, that's probably I will get where I am. So I can hit that immediately. It will resolve the thing. It will give me now a third point, or third design point. And this is gaming for engineers, but you can tell your boss you're sitting and playing with Discovery all the time. Right, so there we even we are still a little bit more than what we were at, but I think it's a good idea to show it like this, right? The other thing I can do is I can define some parameters and do some studies. So I'm going to do variations on this. I have to define a couple of parameters first, right? So let's go back to the design geometry. Let's make that dimension there, the 2.5 millimeter parameter. All right, so we want to see how that size there is influencing the result. Okay, we can also add another one. We can add that parameter there, so hidden behind that little monitor. I can put this somewhere around here. Right, let's go to variations. And in this window here, I just want to update the current one quickly so that it calculates the values. Right, so there's the current design point where parameter 1 is 2.5, parameter 2 is 4.5. It will give me a max velocity of that. There's the pressure drop through the valve, and the temperature will be the same. I can omit that if I want to, and there's the mass flow. I can add a design point now, or variation, and let's see what happens if I change that venturi diameter to 3 millimeters, for example. And then I can tell it to, let me just select that one and make that the current one, and update that design point. Let's take a couple of seconds. You can see there's a little stop sign to that parameter value, so it's busy recalculating my whole design. And once again, the better graphics card you have, the quicker this will happen. I don't have the greatest card of all the cards available out there. So yeah, it gives you a good idea. Right, there's the result. You can see how I'm monitoring the mass flow. I can do another variation, and this time I can say, okay, what happens if I make this a little bit smaller or a little bit bigger even? It doesn't matter what. Let's do a 4mm one. And I can tell it to, there's an option here to update all design points. So then it will recalculate all of them. And this will take a bit of time. So this is the explore phase. So we had the model phase where we model the geometry. Then we've got the explore phase where you can play around with design parameters. And this has got a separate GPU solver, and that's called the Discovery solver. And it's got its own method to calculate the results. The next step would be, I just want to let it finish that design point. The next step I'm going to show you is the real Fluent GPU solver. And that's embedded in here. Now, the fact that Ansys has embedded the Fluent GPU solver inside this thing tells me that this is the new face of simulation that we will see in 10 years' time. And everything that Ansys offers will be sitting inside this interface. It will run on a GPU natively. I don't know who of you are aware of the acquisition of Synopsys. Synopsys bought Ansys last year. It will become effective in January. And Synopsys is a company that is specializing in chips, in silicon chips. So they write the software for that. The reason why they bought Ansys is not very clear. They've got obviously a plan with it. My prediction is that they want to enable simulation on chip level. So if you've got some sensors or some electronics, you will be able to do some simulation on that chip. It will not mean anything to our business. I think we will carry on as usual. But I think this product will be developed tremendously with that acquisition. Right, they're the calculation. Yes.
Sorry, are they changing the name of Ansys, or is it just what does it stay the same?
Oh, we don't know.
Okay.
we know nothing. So the acquisition happened in January. Then there's 1 year of it's like a cool down period where everything is operating as usual. Because there's one product that Synopsys has got a monopoly for, and that's optics. There's some optics products.
Okay.
So they have to approve that in some way. Yeah, that's interesting. But connect with me afterwards. I can share a lot of my suspicions with you in a separate meeting. All right. Cool. Thanks. Then, all right. So there's the results. You can see how the flows are changing, or the mass flows through that inlet. It's changing very nicely, and you can get very quickly valuable results out of a concept phase from this software. Okay, next stage. Let's close this for a second. I can go now to the refine stage, and this is more traditional CFD, right? There's a slider on all of these that indicates the accuracy. I'm going to make it a bit low now so that everything happens very quickly. And I can tell it to show the mesh. You'll see it's busy compiling a mesh. And this is now GPU meshing, so it's quite quick. You will also see that this works the traditional way. This is basically the Fluent solver that has been rewritten to run on GPU. I don't have a great GPU, and you will see even on mine, it's quite quick. Once it has the mesh, yes.
Question, sorry, is the GPU, is that specific license for it to use that, or is that standard?
Yeah, I will show you at the end of the presentation how the pricing works. So you pay basically, there's three modes of discovery. The one mode is just a modeling part, discovery modeling. It's like the old space lane. The second mode is the discovered part. That's Ansys Discovery simulation. And then there's this refined part. You have to buy an add-on, a simulation add-on, to be able to do this.
Okay.
So it is 3 license levels. So we did a demo the other day to a company that's making valves, for example, and they are. I think I have to just totally confirm change. We go. So there's the Fluent results. Sorry, guys. to get back to my example of the company we dealt with, they don't need to refine phase. They got, actually, we did a case study compared. It's flow through a valve. We did the simulation in Discovery Explorer, which is the previous version, previous tab. Kind of, we did it in this refined version, and we did it in full Fluent. And they had experimental data, and the Explore phase results were actually exactly on par with the measured data. The reason for that is Fluent most probably is more accurate than Discovery. But with the assumptions made in the tests and the assumptions made in Discovery, it's very realistic, because it's like losses and things that's in there that the test setup couldn't capture. They couldn't make it any finer than that. But the difference between accuracy between Ansys Discovery and full Ansys Fluent was roughly 8%. And that's very good, in my opinion. It's also very usable, because if you have to specify trends, for example, the mistake will be the same for all the design variations. Right, I need to minimize this thing now. I want to go away. Okay, let's go to velocity. This is now the Fluent solver, right? It's giving you that result. There's the mesh. You can see the mesh now nicely. I can plot some fluid lines. You can see from the Fluent solver, we can see some swirl at the end there. You see it? That's perfect for mixing, by the way. I should keep this design. For mixing, that's excellent. A nice mixing of the flow. You can also animate the result. It'll show you that kind of thing. Oh, I solved it in the wrong direction. Did I? Yeah, I need to reverse the numbers. Right. And then I can go now and I can refine this. Pause it there. I can even refine it further so that it creates a finer mesh. So let's just do that for a second. My graphics card is blowing away currently. Let's just wait for this while we talk. You see how quick that mesh was? That's a pretty cool mesh, guys. It's not perfect. Let's do it again. We'll get some. There's the mesh statistics. 156,000 elements. There's the new mesh. I just want to look at the. Okay, the solver just has stopped there. I don't need to continue further. I think our time is almost up anyway. But I think that gives you a very good idea on how this tool fits into the engineering toolbox. Any questions, guys?
Is there a symmetry feature?
Sorry?
Is there a symmetry feature for, like, if you're doing much bigger simulations?
Not in Discovery yet. I believe that's a very easy thing to do in the solver, right? So I believe in future releases, they will start adding that. The initial direction with the solvers that they took is they introduced the Fluent GPU solver into this product about 2 years ago. And once that solver is in here, it's really the sky's the limit. They can add as much as they would like. They just need to represent the code for a GPU, because you offer code differently to a CPU solver and a GPU solver. There's quite a big difference to offer to be able to do that. Oh, I see there's a lot of people who joined us. Hello, everyone. Right, I think that concludes my demonstration. I think Laura, if we can send everybody the discovery capability chart, and then I'll say something about the pricing quickly. Who's interested in pricing? Is anybody interested in pricing?
Yeah, it would be good to know.